Okay, so the next problem we are solving in the lead code is container with the most water. Okay, so basically here consider this as a ground. Okay, and we have a different pillars here. Okay, and if you pour a water into it, like kind of a beaker type. Okay, like if you pour a water to into it, like I mean, which two pillars can hold the maximum amount of volume of water? Like I mean, that is a question here. Okay, so let's consider. This pillar, okay, this pillar and this pillar. Okay, and if you pour water into it, obviously like the maximum it can hold is till here, correct? Whatever the water we pour with, the rest will be going overflowed, correct? So basically that's what we'll have to find. We'll have to pick any two pillars, okay, and we'll have to find the value. And now the answer question is, we'll have to find out what is the maximum value that we can hold in this configuration. Okay, so what we'll ideally have to do is, we'll have to pick the two pillars here, and we'll have to do the calculation value and compare it with the previous one, and whichever is the maximum, we'll be doing it again and again, and we'll have to return it. Okay, that will be like I mean brute force approach. That instead of that, right, to reduce time complexity, what we can simply do is we can use the two pointer approach here. Okay, so one pointer will be pointing to this and another pointing to this. Okay, so before actually jumping to that, let's try to understand the formula to identify the value, right? So this is nothing but, let's say that we are pouring the water between these two, right, highlighted pillars, and obviously the volume will be this is rectangular, right? Rectangle, if the rectangle means like the area would be just length versus breadth, correct? So that's how the formula would be, correct? And now for this one, what we'll be doing is, while calculating the value, we'll be first identifying the minimum height. Okay, like we cannot be considering the length as this one, right? We'll be considering the minimum one. Okay, minimum of that. Okay, minimum of height, either whichever is smaller, and into the breadth one. Okay, the difference between the this pillar and this pillar. Okay, that will give us the current value. Okay, now coming back to this, what is the approach with respect to two pointer is, we'll set our pointer, one pointer to here, we'll set another pointer to here. Okay, and we'll do the calculation. Okay, the calculation would be ideally from here to here, correct? The height would be here, and we'll be doing the calculation for that, and we are good. We'll do the calculation, and initially we'll assume that the maximum value we can get is 0. Okay, and we'll do the comparison, whichever comes greater, we'll be updating our max value. So we'll do the calculation, we'll update our max value. Okay, initially it was 0, now it will be getting something better, correct? Height is 1, and I think this will be 7, so the maximum value will be updated to 7. So now the actual logic comes in. So what is the logic here is, so ideally we are looking for a maximum value, right? So what we need to do here is, we'll have to take a approach that will result in a maximum value, right? How we can do here is, so currently we are here and here. How we can get a maximum value? Obviously if this height goes bigger, right, in that case we can get a maximum value, correct? So what we'll do is, we'll try if there are any pillars next to it. If there is any bigger, we can get a bigger value. Okay, so that is the approach here. Let's say that whichever is smaller, we will increment that pointer. Left is pointing to this, right is pointing to this. So here left is lower, so we'll increment our left pointer. So now it is pointing to this. Okay, we'll do the same calculation, and then again we'll check left and right pointer height. So now this is smaller, right? If some other pillar which is higher than this can result in maximum value, correct? So what we'll do is, we'll decrement the right pointer. Okay, we'll decrease the right pointer, and then do the same calculation again and again, until left pointer is still left to the right of right pillars. Like I mean, if it crosses one another, it means, obviously means that we run out of all the combinations, and whatever the calculation that is done so far, we'll be returning that. Yeah, that's it. Thanks.